You're standing at your kitchen window with a cup of coffee. A chickadee lands on the feeder, takes one sunflower seed, and flies off into the yard. 3 seconds later, it's back. Takes another seed. Gone again. You've watched this happen 50 times and you've always assumed the same thing. It's eating somewhere nearby. It's not. That chickadee is not eating. It's building a warehouse. Every seed it takes from your feeder gets hidden somewhere in your yard, tucked under bark, pressed into soil, wedged into a crack in a fence post. And here's the part most people never consider. Oi, ore mime soy. It will find that seed again. Not by smell, not by luck, by memory. Precise, specific, location-locked memory of a kind that neuroscientists spent decades assuming birds simply could not possess. What's happening at your feeder right now is not a bird eating. It's a bird running one of the most sophisticated spatial memory operations in the animal kingdom. And the other birds in your yard, the ones watching from the branches, are calculating whether to let it finish or move in and take what it buried. Welcome to Bird Instinct. This channel is about what's actually happening in the yard you walk past every day, not behavior in the abstract. Your yard, your birds, the specific intelligence operating 10 feet from your back door. Subscribe so you don't miss it. In this video, we're going through the science of avian caching memory, how birds store thousands of locations simultaneously, why their brains physically change with the seasons to support it, and how they know when they're being watched. Stay until the end because the last thing we cover is the most unsettling part. Researchers at Cambridge spent years documenting what happens when a bird believes you have been observing its hiding spots. What it does next says something about the nature of bird intelligence that science is still trying to fully categorize. The chickadee at your feeder has a hippocampus, the brain region responsible for spatial memory, that is proportionally larger relative to body size than the same region in most mammals. A study from the University of Colorado measuring hippocampal volume across bird species found that food-caching birds consistently showed significantly enlarged hippocampal tissue compared to non-caching species of similar body size. The chickadee at your feeder is not operating on instinct when it hides food. It is making decisions, storing coordinates, and retrieving them on demand. Each chickadee maintains between 1,000 and 5,000 individual cache sites during a single fall and winter season. These are not approximate locations. Researchers at the University of Washington tested chickadees in controlled environments by letting them cache food, altering the visual landscape, then allowing retrieval. The birds went directly to exact cache coordinates even when the surrounding visual cues had been rearranged. They were not navigating by landmarks. They were operating from stored spatial data. The memory doesn't persist forever. Chickadees maintain cache locations accurately for approximately 1 month, which aligns precisely with how long the food remains viable. After that, the memory fades, not because the brain fails, because the brain actively releases the old data to make room for new caches. This is not a limitation. It is a feature of a system built for efficiency, not permanence. Now here's the part that requires a slight reframing of how you think about seasons. Every fall, as the days shorten and temperature drops, something happens inside the skull of every chickadee in your yard. The hippocampus grows, measurably, physically, documented on MRI. Researchers at Rockefeller University tracking seasonal hippocampal change in black-capped chickadees found the hippocampus increases in volume by approximately 30% in autumn compared to its summer baseline. In spring, when caching behavior slows, it shrinks back. This is not metaphor. The bird's brain is physically rebuilding itself to handle the cognitive load of what it's about to do. New neurons grow. Connection density increases. The bird that lands on your feeder in October is neurologically different from the bird that was there in June. More capable, more precise, running on upgraded hardware that it grew specifically for the task of storing and retrieving food through winter. When you watch a chickadee hit the feeder and disappear into the yard over and over on a November morning, you are watching a brain in active construction season. It is caching food and growing the neural architecture to track it simultaneously. The jays in your yard operate at a different scale. Blue jays can cache tens of thousands of acorns in a single fall season. Researchers tracking individual blue jays with colored leg bands documented birds making up to 3,000 individual caching trips across a 6-week window, with each trip involving multiple seeds buried at separate locations. The spatial memory required to track this is not qualitatively different from human episodic memory, the kind of memory humans use to recall where they left their keys, or what happened last Tuesday, or where they parked their car. But the jays don't just cache and retrieve. They manage social risk, and this is where the behavior becomes harder to categorize simply as instinct. Nicola Clayton at Cambridge University spent years running a specific experiment with western scrub jays, a jay species found across the western United States. The setup was straightforward. Jays were allowed to cache food. Sometimes another jay was watching. Sometimes the area was empty. Clayton's team then tracked where the jays went after the observer left. When a jay cached food while being watched, it consistently returned later and moved the cache to a new location, but only after the observer had left. If no bird was watching during the original caching event, the jay left the food where it was. The re-hiding behavior triggered specifically in response to being observed. The implication took years for researchers to fully accept. The jay was not responding to a stimulus in the moment. It was doing something more complex. It was remembering that it had been watched, modeling what the observer might now know, and acting preemptively to protect its food from a theft that had not yet happened but that it anticipated. This requires a bird to hold a mental representation of another bird's knowledge state, to understand at some functional level that what the observer saw during the caching event creates a future risk. Clayton's paper, published in Nature, described this as evidence of perspective taking, the cognitive ability to model what another individual knows or does not know. In humans, this is called theory of mind. It appears in children around age 4. It was not expected in birds. There is an additional detail that matters. In Clayton's experiments, the jays that re-hid their food when watched were specifically the jays that had themselves stolen food from other birds in the past. Jays with no prior theft experience did not show the same recaching response. The bird that has stolen knows what a watching bird means. It is projecting its own experience onto the observer. It is assuming the other bird will do what it would do. The bird at your feeder right now has a behavioral history. It has cached food, it has probably stolen food, and it has been making decisions about who is watching when it does both. This brings us to your yard specifically, and to you. Catching birds track observation. They register the presence of individuals near their cache sites. Multiple studies have documented that caching behavior slows or stops when a human observer is too close to the caching area. The birds are not just avoiding movement. They are specifically avoiding allowing their cache locations to be observed by something that might compete for the food. What this means for the bird at your feeder is that it has been assessing you. It knows where you stand. It knows which window you look out of. It knows whether you move through the yard during its caching runs or whether you stay inside. It has been incorporating you into its risk model since the first day it started caching near your property. You are not an anonymous presence in its environment. You are a known variable. Here's what you can do with this. If you want to watch caching behavior directly, stand well back from the yard and stay still. Binoculars from a window are better than standing outside. A bird will pause a caching run the moment it registers a close observer. You will miss the behavior by being too close to it. Distance gives you access. If you want to support winter caching, prioritize sunflower seeds and peanuts over mixed seed blends. Caching birds select high-calorie, dense foods for storage. Low-calorie seeds are eaten on site. High-calorie seeds get buried. A feeder stocked with shelled peanuts in October will generate caching behavior every time you watch. Researchers tracking Chickadee caching rates found that high-fat food items were cached at 3 times the rate of equivalent-calorie, lower-fat alternatives. You can also mark a small area of loose soil near your feeder and watch it. Caching birds return to soft ground repeatedly. Give them an easy target, and you can observe the exact moment of burial. And if you wait, the exact moment of retrieval. Go back to the chickadee at the beginning. The one landing on your feeder, taking a seed, flying away. You can watch that happen 100 times and see a small bird eating. Or you can watch it and see what's actually there. A brain that grew new neurons this fall specifically to handle the task it's currently running. An animal that tracks thousands of locations with sub-centimeter precision. A creature that knows when it's being watched and adjusts its behavior accordingly, not because it's afraid, but because it is running a calculation about future risk that requires modeling your intentions. That bird is not passing through your yard. It is operating in it. It has been mapping it, caching into it, and monitoring everyone moving through it, including you, since fall began. The next time it lands on your feeder and takes a seed and disappears into the yard, you know what's actually happening. Subscribe for a new bird story every week. And if you've ever caught a bird in the act of caching or watched one steal from another, tell me about it in the comments. I read every one. I'll see you in the next one.